Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog.
What's up, Gophers? KubeCon Cloud Native Con is happening next March in Amsterdam. Early bird registration pricing is in effect right now. Plus, as a special bonus for GoTime listeners, you can get an extra 10% off the already low early bird registration pricing by using the code KCEU GoTime. Again, KCEU GOTIME. That's KC for KubeCon, EU for Europe, and GoTime for GoTime. You have to hurry up though because this coupon code is only active when early bird registration is active, and that ends November 8th. Check the show notes for links to learn more and register.
Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Gopher Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello and welcome to Go Time, the show where a diverse panel and special guests discuss all things Go is known for, including cloud infrastructure, distributed systems, microservices, serverless, and especially today, the very popular and open source container orchestration platform, Kubernetes. My name is Johnny Borsico, and joining me today is a stellar cast of characters, as Matt Ryer would say, including Matt himself, and two other folks who know a lot about Kubernetes. Please welcome Joe Beda, formerly the CTO of Heptio, now part of VMware, and Kris Nova, author extraordinaire and all-around Kubernetes guru. Hello, everybody.
Hello.
Hey.
Hello. It's very, very good to have you on the show today. So this is going to be a nice sort of little back and forth. I know a lot of people listening to the show know, or at least think they know a lot about Kubernetes, but I do want to sort of level set a little bit. So this is something that we like to do on the show to be approachable for both beginners to Go, people that are part of the community, haven't been part of the community for that long, and for those who sort of know the goings on and they know that Kubernetes is made out of, a lot of Go behind the scenes. Let's start out by basically figuring out or really unpacking what it means to have container orchestration and where sort of a Kubernetes fits into that whole picture.
Now, Nova, do you want to start out or do you want me to give a sort of my quick sort of 5-minute, what is Kubernetes?
I want you to do your 5-minute Kubernetes so I can pick on it afterwards.
Okay, yeah, you can tell me where I'm messing up. Well, assuming that folks sort of have a good grounding in containers, where a container, just to really level set here, is taking a program plus all the things that it depends on, packaging that up into a thingy and making it so that you can take that thingy to different machines and run it in a predictable way, right? So it's really about sort of program portability. Now, I think folks in the Go world with, static linking and, bringing everything in are kind of spoiled, where you can take a Go binary and it pretty much runs wherever you want to run it. But try doing that with a Ruby app or a PHP app or a Python app or a Node app or whatever. And so not everything is hermetic as Go. And so packaging things up as container is great. And so obviously it was Docker that made containers super, super accessible and easy to use. But the original Docker only did that for a single computer. Whereas our experiences at Google building similar-ish type of systems over about 10 years was really that the stuff gets interesting when you start looking at containers and that portability across many computers. And so what Kubernetes does is you tell it what you want to run. I want to run 10 copies of this container image. The image is the thingy. And then it decides where to run these things. And it makes sure that they keep running over time. And then once you do that, there's a bunch of other problems you have to solve. What does networking look like? What does storage look like? How do you have these things find each other? How do you actually manage load balancers that point to a set of these things? So there's a whole bunch of sort of problems that are downstream of that sort of dynamism of assigning programs to computers. And so that's sort of like Kubernetes from an orchestration point of view. Along the way, we ended up building essentially a generic, distributed system kernel for being able to describe not just how you run containers, but which containers you want to run, how you upgrade them. And we made that extensible. And that's where a lot of the sort of interesting stuff going on right now is in the ecosystem.
Yeah, and then I think just to follow up on that, you knocked it out of the park as per usual. I think the only thing here I would want to call out would be just the importance of the APIs as we've been building them out over the past, it's been 4 or 5 years now. So like you said, Joe, it's sort of a distributed systems kernel, but really the value here is being able to standardize on this across the industry. And, this is for the first time we're seeing folks come together and defining their applications, defining their networking, defining their storage all in the same way. And that's a very powerful primitive in the cloud native ecosystem.
Right. That whole term. So this whole cloud native terminology, right?
I can define that one for you if you want.
Yes, please.
All right. So I assume that there's going to be a lot of folks who are going to disagree in terms of the definition of cloud native. And so Nova wrote a book on this also. So she's probably the expert, but I'm talking right now, so I'll finish up. Sorry, Nova. In my mind, cloud is essentially running on somebody else's infrastructure where you have it's API driven, it's self-service, and it's elastic, right? So from the point of view of developers, cloud is often like not talking to a sales guy as a service, right? You can just walk up and drop a credit card and get going. And that's really powerful. And I think you can still take those sort of API driven self-service. You can apply that sort of inside of an enterprise where somebody else might be another department. But if you're doing it right, you still have that sort of, self-driven experience for application developers. Cloud native in my mind is, tools, culture, processes to take the greatest advantage of that. How do you actually take that capability, API driven self-service, and then back propagate that to how you build software? What's your definition, Nova?
Again, you're stealing all my good one-liners here. I think that was a really good way of defining cloud as like a sort of a first-class primitive. But I think when I think cloud native, I think cloud is one thing, but native is this whole other thing that I feel like gets overlooked a lot, which is on day one, walking up to the dry erase board, your terminal, wherever you're writing code, wherever you're designing your systems, day one, designing it to be ran in the cloud. So we're looking at a lot of like lift and shift or taking in an existing legacy application and moving that over. In my mind, that's just taking a legacy app and running it in the cloud. That's not necessarily a cloud native application. So again, it's starting that main function with the cloud in mind.
Yeah. So how did the project start then? Did it come out of the work you were doing at Google and then the open source project kind of spawned from that?
I started up Google Compute Engine, which was this weird thing of running VMs at Google because like hardly anybody did anything with VMs at Google. And it was really about sort of establishing the infrastructure cloud for GCP. And, you look at any major cloud and like VMs are sort of the cornerstone service that everything builds on. Inside of Google, nobody used VMs because they used this system called Borg. It was, kind of a little bit like Kubernetes. The idea of container and the way it gets packaged up in images, all that stuff is different. But the general idea of like you describe your program and then you have a system that schedules it and runs it had been sort of proven out over 10 years at Google. And so we understood the benefits to developers and the efficiencies that you can get from that. And so we were in this bind. I mean, there was a couple of things that we wanted to do with Kubernetes. So the first thing was essentially, change the game as we were competing with other clouds. And so folks like Amazon were running away with this market. And so the way, we could have sort of gone head to head on VMs, or we could have also decided to try and get folks to write programs a different way in a way that speaks to how the strengths of Google Cloud. And then the second thing was we wanted to start bringing into alignment the way that folks built stuff internally versus the way customers built stuff. So that the experience that internal Googlers were running with was closer, if not identical, to the way that external customers were running. And then, we definitely had a sense that none of this stuff would have had an impact if it wasn't open source. And so we really saw open source as being absolutely necessary from the beginning. And by committing towards truly being open, like from day one, we're like, hey, you can run this on Amazon, which really surprised folks. We also did things like brought in a lot of great folks from Red Hat, and Red Hat was a great partner early on in terms of really expanding sort of the set of scenarios and the thinking behind Kubernetes. And so, yeah, that's how things got started.
No, that's a really interesting story. And then, of course, yeah, the whole sort of problem, it's really interesting because I was an App Engine user for a long time. Although it's not clear from the outside, it's not publicly represented in any way. I can see now the difference when we use App Engine to what it was like before. And I can only imagine what's gone on underneath, something to do with Kubernetes and containers, because it definitely feels more natural for deployment just from an App Engine point of view. Is that right? Something like that happened on that project?
Well, I think, App Engine's seen its own evolution. I don't want to speak for that team necessarily, but there was always a little bit of a tension between, honestly, GCE and App Engine. And I think some of that actually applied to Kubernetes and App Engine also. I just gave a talk last week at the Spring One Platform Conference. And one of the things I talked about was a little bit of the sort of the difference in philosophy between infrastructure as a service and platform as a service. Infrastructure as a service, fundamentally, it's a set of building blocks. It's a set of Legos that, it's a toolbox that you can construct all sorts of different things out of. And that applies to both VMs, but I think Kubernetes is still at that sort of toolbox level. Whereas I think as you get closer to platform as a service, it becomes much more of a framework where there's sort of preferred patterns. If you don't adhere to those patterns, then it's definitely a lot harder to use or impossible to get what you want to get done. And so that can oftentimes be very productive, but it also can sometimes be limiting too. And so I think we're, looking forward, we're trying to enter in a world where there's not nearly as sharp a line between these two different perspectives, these two different ways of approaching these problems.
So in my mind, I'm trying to picture sort of who in the organization or what role, who does this fall to? Like basically, am I to look at Kubernetes as the thing you deploy applications on, or am I to look at it as the thing you use to build the platform that you deploy applications on, right? So is it a platform builder or is it the platform?
So I think that, and I'd love to get Nova's take on this too, but I think that there's roughly 3 personas for Kubernetes right now. What we find is that there's the platform teams. And I think the most forward-thinking organizations think about sort of platform as an internal product. How can they provide something that lets them scale out, provide a larger menu of services to their internal teams, and in some ways provide a cloud-like experience, but sort of on the, within the constraints of that larger organization. That's how we see this play out in enterprises a lot of times. And then you have application operators and application developers. And it's really the application operators that run on top of, that interface with Kubernetes. And sometimes people wear both hats, right, in a sort of DevOps-y type of way. But then I also think when we look at those platform operators, oftentimes they're going to want to say, hey, there's raw Kubernetes, but also using extensibility, using other systems, we actually have a preferred way to use Kubernetes that's going to be easiest. And it's sort of like, through the fullness of time, we want that preferred experience to be similar to the experience of a PaaS, where developers can just show up, get stuff done. The ops role is much diminished in terms of sort of the drudgery. And it starts feeling more like, these like, hey, I write code, I ship it, and then it just runs type of experiences.
So following up on that, and we talk about this in the book Cloud Native Infrastructure a little bit, I think there's a fourth role. I think there's what we called in the book an infrastructure engineer. And these are effectively the folks like Joe and myself. These are the folks who are writing software to manage and mutate infrastructure behind the scenes. Folks who are contributing to Kubernetes, folks who are writing the software for the operators, folks who are writing emission controller implementations and so forth. And I think that's this very new engineer role that we haven't seen until we've started to look at having effectively, as Joe likes to put it, a platform.
Mm-hmm. So along those lines, which actually brings up something that I saw earlier on Twitter, these roles require so much from an experience standpoint that it would be hard to have, say, a junior developer, right, join one of those teams and be able to contribute effectively. Is the barrier to entry, right, to be able to contribute to something like that just so high that I see folks hiring, the job postings are like a mile long, and you need experience in this, you need experience in that. So it seems hard, or rather, at least from my standpoint, it seems like the barrier to entry there to be able to effectively contribute in such a role is quite high. Is that true from your experience?
So my thoughts here are, it kind of depends on how mature your team is, right? Like if we had infrastructure engineers and platform folks already in place with systems in place to, build out an application image and push it to production, then I think the barrier to entry here is pretty low. It's effectively writing an application of your choosing in a language that you want and letting the systems that are in place sort of take it from there. Now, getting those systems in place is a completely different story. And that's where I think we see the high barrier to entry with folks who are coming in and having to answer, how do we start implementing solutions for the various stages in our build pipeline and pushing to production?
Yeah, there's definitely a lot for folks to wrap their heads around. If we call Kubernetes a distributed system kernel, right, then the folks who are extending it, the folks who are going deep on that, in some ways they're kernel engineers, right? And for somebody to actually become an expert in Linux and go deep on the Linux kernel and understand the ins and outs of the system, like that's not an easy thing to do, right? And I think a lot of, one of my observations here is that a lot of this stuff is new, but if we look at AWS, right, and you look at the menu of services there, like that's not easy, right? There's a lot to wrap your head around. There's a lot to understand. It's a full-time job over months to actually become proficient on AWS. That's why they're doing things like Lightsail. And I think, it's going to be a similar thing for any sort of advanced, cloud-like system. There's a learning curve to actually pay for there. I think one of the things that we see is that there's similar learning curves for things like being proficient on Linux at all, but it's a shared thing and it's assumed and people climb it together. And over time, it sort of becomes part of the background noise of actually just being in our industry. And I think we're seeing the same thing happening with cloud, where a certain level of proficiency with Amazon is almost expected in background noise to some degree. And I think we're going to find that, if Kubernetes continues on its trajectory and becomes more of sort of the common substrate, then proficiency, or at least a working knowledge of Kubernetes, will become part of the background noise for being proficient in our industry.
And speaking of the sort of open source teams, this project, when it started, presumably it started like most projects do, much smaller, with a smaller scope, I assume. I don't know. As that evolved and as that changed over time, were there any surprises in that? Or what were the interesting things that you saw happening?
So I think the interesting thing for me was even getting Kubernetes up and running, which again, Joe wrote the book on this one. But I've noticed, both in the open source ecosystem as well as in the commercial enterprise, going from zero to Kubernetes has always been a high point of friction for a lot of folks. So, looking backwards in time, that was what originally attracted me to Kubernetes in the first place. And I think that I was surprised that we've come as far as we did, and we still don't have necessarily a great story here. Now, I think we're getting close with projects like the Cluster API and tools like kubeadmin. But again, I still think that there's a lot of questions that need to be answered to this day when it comes to going from zero to Kubernetes.
Yeah, I think that's the biggest surprise for me also. I mean, early on in Kubernetes, I wrote a pile of bash for deploying Kubernetes in a bunch of different environments, GCP and some other stuff. And it didn't age well. Let's just put it that way. I actually wrote a way to dump a stack trace in bash. It's like, I'm kind of both horrified and proud of that. And so I don't think we took seriously enough sort of the life cycle of the cluster itself, running it, the different types of environments that it runs. How do we actually build deployment systems that scale across all those environments? Because launching a cluster in, a major public cloud provider is a very different experience than doing a cluster on bare metal, doing a cluster with Raspberry Pis, And so I think one of the strengths of Kubernetes is that it scales from everything from like we have retailers putting it in every store. I think Chick-fil-A is an example of this, where they're using that to run their in-store systems like point of sale and digital signage and stuff like that, all the way up to examples like, the particle accelerator at CERN. They're essentially using it for data analysis there. And so that's a huge scalability. But what that means is that the way that you administer it, the lifecycle actually changes across those things. And the complexity that brings, I think, is something that we very much underestimated early on in the project.
So one of the things that you might tend to hear in the industry is that if you go to a few conferences, you're going to hear like, well, we're going to use Kubernetes so that we're able to deploy across all the clouds. That's going to be our primitive, if you will, that sits on top of everything else. And that way we have the freedom to move from cloud to cloud or to use all of them at once if we want to. Do you think that's a wise thing to do? Should companies and developers and teams be building sort of at that higher level without really taking advantage of any one cloud's particular strengths?
Well, my take on it is I think multi-cloud strategy can make a lot of sense for a lot of companies. Now, first of all, if you're a startup and it's all about proving that you can add value to the world and not going out of business, do everything you can by hook or crook to actually get to that point where you prove your value proposition. But I think as we look at more mature businesses, it's really a matter of risk mitigation. I think that these companies look at dependence on a single vendor as risky. And if there's ways to actually mitigate that risk, it's worthwhile. And Kubernetes can be one technique on how to do that. I think what it also does is it creates sort of a clear separation of operations roles. You can have specialized teams that know how to run and manage Kubernetes on top of infrastructure X, Y, or Z. Maybe use services for some of that, and you can sort of outsource some of that. But then what you end up with is some commonality in terms of experience at the application level. Now, we may not be able to hide every detail of the underlying platform, and there may be places where you want to take advantage of special cases of the underlying platform. But if we can reduce the sort of gratuitous differences, we can make application teams and that skill set more portable. We can make applications more portable. And I think one of the things that we see with businesses is that it ends up being a point of leverage between them and their vendors, right? So if you're going to Amazon and you're a big customer and you're negotiating your discount because that happens. If you're 100% sort of, locked into various primitives, you're not going to get as good deal unless you're a credible flight risk. Unless you can say, hey, we can credibly, it'll be a 2-month project, but we can move from infrastructure A to B. All of a sudden, that actually creates, a much more even playing field between you and your vendors.
So following up on what Joe was saying there, I think getting the abstraction right for as we start looking at defining applications, networking, storage, what have you, across clouds, part of a very interesting mental journey that we went through when we were starting to look at designing the cluster API was that no matter how generic you make it, you're pretty much always going to run into a situation where there's going to be some cloud-specific something that you're going to need to define. And so it's an exercise of trying to figure out, one, what are the generic parts, and then two, how do we minimize the amount of configuration you need to define for a given cloud. And I think if you look at how we're using the provider config in the cluster API, you can really see that we're able to start versioning cloud-specific bits while still maintaining a generic superset of configuration as well. This is just coming out of lessons of when we were designing the API for COPS, when we were doing it for Kubicorn, and trying to make it as generic as possible, and eventually running out of ways of making it generic. So again, if you get a chance to read my book, we talk a little bit about some of these primitives of how you would effectively use software to manage the lifecycle of a Kubernetes cluster. And if you look at one of the most fundamental principles of Kubernetes, it's declarative in nature. In other words, you define what the goal is or the intent here, and then we just go and reconcile that state over time. All the cluster API is taking that original lesson and then applying it to infrastructure. So you start off by first declaring what your Kubernetes cluster should look like, and then we go and we reconcile that and try to bring it to life. Now, this is helpful when we start looking at the life cycle of the cluster, because if we want to make changes to our cluster, if we want to scale it, if we want to upgrade it, if we want to mutate it in some way, we are following these same principles of declaring what we want and letting something take action behind the scenes.
So the way I would say it is that we're essentially using the Kubernetes patterns that have been proven at scale to manage Kubernetes itself.
That makes sense.
Does it? It sounds like Inception.
No, yeah, there's definitely, it's like the logo for the cluster API project is a stack of turtles because it's turtles all the way down.
Yeah, right.
Nice. So we do have a question from our GoTime FM Slack channel. And for those listening, yes, when we record live, we do take questions live. So this is your opportunity. You've been told. So Ian asked in a channel, is Kubecorn still alive or has it been displaced by Kubeadmin and COPS?
That's a good question. I do know that folks, myself included, use Kubicorn from time to time. I don't think it was ever intended to be production ready or to solve, managing a Kubernetes cluster at scale in the enterprise. I think it was a good thought exercise. And I think that probably the biggest piece of value that I got out of it was the first open source Kubernetes management tool that was built on top of kubeadmin. And that is still in place to this day. And if you actually look at how Kubicorn works, it's relatively static at this point because we're able to just vendor kubeadmin at runtime with the latest version that is being pushed by the upstream folks. So the way I look at Kubicorn is it's just a way of automating using kubeadmin to set up a cluster. So I think that we learned a lot with Kubicorn, we learned a lot with COPS, we learned a lot with kubeadmin, and I think Cluster API is a really great representation of taking all of these lessons together and coming up with a way of doing this together as a community. So long answer, it's not necessarily growing, but I wouldn't say it's necessarily dead either.
This episode is brought to you by Datadog. Datadog is cloud monitoring as a service. See inside any stack, anytime, at any scale, anywhere. So what's new with Datadog? Coming off the heels of Dash 2019, Datadog's annual conference about building and scaling the next generation of applications, infrastructure, and technical teams, we have a lot to cover. Serverless functions. Datadog Serverless View gives you complete visibility into your code running on AWS Lambda. Browser logs. You can now send logs directly to Datadog from web browsers or other JavaScript clients for full stack visibility. Network performance monitoring. This enables you to visualize the flow of network traffic in cloud-based or hybrid environments. Mobile application. Datadog now has a mobile app to make it easier to triage issues when you're on call or on the go. Real user monitoring. This enables you to visualize and analyze the performance of your front-end applications as seen by your users. And a final list of what's new: log rehydration, metrics from logs, watchdog for infrastructure metrics, metrics without limits, tracing without limits, trace outliers, and so much more. Head to datadog.com/GoTime to learn more and get a free t-shirt. Once again, datadog.com/GoTime.
It's funny, there's something that I've noticed, it's kind of been mentioned a couple of times already, and it's sort of this theme that I'm quite interested in around the fact that this idea and these projects have to evolve. You almost, you talked about underestimating the complexity of deploying to different targets, and that's kind of a good example where you almost have to underestimate that at the beginning, otherwise you probably would never undertake some of these projects, which end up being enormous in scope and in power and in capabilities and things. So it's that idea of that you couldn't design this in a vacuum. You have to sort of build it and have it be used and get it out in the real world before the software can get good and get hardened and stuff. Would you agree with that?
Yeah, a couple of things is I think we did have a pretty clear idea of what we wanted Kubernetes to grow into when we started out based on the experiences with Borg. But there were definitely areas where we skimped out the gate and, tried to simplify things to just get started. You need to just get started on this stuff. I think then also as the project grew, there were things that I think where we expanded scope. So I think early on, we recognized that this was probably three and a half years ago. We recognized that as we added more and more capabilities to Kubernetes, number one is that we wouldn't be able to keep up with all the ideas that folks had. And number two is that there's a chance that we're going to get some of this stuff wrong and we need a way to experiment. And so we started creating extensibility mechanisms inside of Kubernetes. And I think that really transformed Kubernetes from being just container orchestration to really being, when we start talking about platform in a technical sense, it really is the underpinnings of that. And then in doing so, it allowed us to sort of keep Kubernetes scoped. And so there's a lot of stuff that's happening in the Kubernetes orbit that is not part of the Kubernetes project. And I think that's part of the success of the thing altogether, is enabling a thriving ecosystem where you can do interesting things on top of Kubernetes without talking to, any of the core Kubernetes developers. And that has really sort of turbocharged the project and I think the ecosystem in general. So much of all the excitement sort of above the sort of Kubernetes interface on the application side of the facing side of the interface is really about, how do you start using Kubernetes not just to deploy applications, but to provide active distributed management for those applications.
It's interesting you talk about that. In what ways is it extensible then? What sort of types of extensibility is possible?
Yeah, so Kubernetes has a bunch of built-in objects that you actually can write to it. So you can say, I want a pod, which is essentially a set of containers. And then Kubernetes, takes care of picking out which machine to run that on and then gets it started. Then you can say, I want a replica set, which means that I want a copy of this particular template. I want 10 of them. And Kubernetes will make sure that you have 10 of them. And then you can say, I want a deployment, which is a version of that. So you can do version upgrades and all that. And so we build up these sort of stack of layers, and there's a bunch of built-in objects with Kubernetes. The core extensibility that I think has folks so excited is this thing called custom resource definitions, or CRDs. It's a way for you to essentially create new objects in Kubernetes, essentially extend the schema of Kubernetes so that you can bring your own stuff to it. So if you say, hey, I don't like the way Kubernetes does deployments because you can't do blue-green deployments the way I want to do blue-green deployments, you could write a peer to the deployment object called a blue-green deployment that implements your logic for how you do this stuff. And so this is really a combination of extending the schema and then running a piece of code that essentially does that reconciliation loop that Nova was talking about earlier that is so core to the Kubernetes sort of way of doing distributed systems. And then the exciting thing is that folks are both applying this to more domain-specific problems. So you can say, hey, instead of managing the deployment of a generic program, I can manage the deployment of a MySQL instance, or I can manage the deployment of a Kafka instance. So we're starting to see this idea of people, essentially taking operational knowledge, rendering that into code, and then having that code run on top of Kubernetes. And so you can essentially create an RDS-like system using this sort of Amazon analogy, but using Kubernetes as a substrate for both describing what you want and actually implementing that logic for how you're going to actually run an RDS-like system. And then we see people applying this to not just running stuff on Kubernetes, but you can take that control pattern and apply it to other things, whether it be configuring a hardware load balancer, whether it be configuring services in a specific cloud. I've also talked to people who have a custom resource definition inside their enterprise that describes a team with who's on the team and what type. And like, as soon as you do that, it creates the Bitbucket repo for them. It creates the Slack channel for them. It automatically sets up their CI/CD system, all based on that essentially declarative document of what you want. And then you have a bunch of these extensions that go out and manipulate these outside systems. And I think that's the exciting sort of distributed systems kernel that I think has sort of given Kubernetes a second wind.
So when I'm talking with folks who are new to Kubernetes and I'm trying to explain to them like the power of CRDs that Joe was just talking about, I usually start off by first defining two very important elements of a CRD that you see throughout every object in Kubernetes, which is the spec, which is effectively the definition of what you would like. It's your declaration. And then you have a status, which is this real-time status of what is currently happening with the object. And because we have both of those at the same time, that's where this reconciliation primitive comes into play. And that's how we're able to build these complex reconcile loops and controllers and operators arbitrarily for whatever we want as a software engineer. And I think a lot of folks don't realize the power and the genius that Kubernetes gives us when it comes time to defining these operators and these controllers.
Well, I definitely think they're going to be looking into it now.
Well, one of the things I will say is that writing one of these controllers, like, it's actually harder than it should be right now. And so that's an active area of sort of exploration where folks are figuring out what are better ways to actually both use Kubernetes like as a user, but then also sort of program Kubernetes to sort of use these automation patterns. And so I think, we still have a ways to go to make this stuff be a lot more consumable, a lot easier to work with. One thing I want to do is I do want to pitch a book. It's not one of mine or Kris's, but it's Programming Kubernetes by Michael Hasenblad and Stefan Szymanski. So, I have a copy that I'm holding right here. If you want to start saying how do I use Go to start programming Kubernetes and start doing some of this sort of CRD and controller loop, this is actually, you can do worse than starting with this. It's an O'Reilly book.
Thank you. Very cool. Thank you.
Yeah, and I think it's important to call out there's tooling in this space as well that we're starting to prototype. There's a solution, the operator framework that came out of the folks at Red Hat CoreOS. We have KubeBuilder, which is an open source upstream effort. And so we are starting to look at ways of building out frameworks for us to start developing controllers and operators. But again, it's a lifetime of iterating and working on it. And we're just not there yet, I don't think.
And to bring this back to Go, I think Go is kind of the preferred language for doing this stuff right now. So there you go.
Yeah, I was going to ask about that actually. If you look at the github.com/Kubernetes/Kubernetes repo, which I guess is the main Kubernetes code base.
We call that KK.
KK, yeah.
Kubernetes, okay. Kubernetes.
Cool. We won't nest that any further.
Yeah.
So I noticed that in the language, tells you the language breakdown, it's over 90% Go. So why was Go the language of choice then for Kubernetes when you started out for this project?
Well, and I think the other 10% or whatever is probably Bash, and that's all me. I'm sorry. I think, we picked Go. Number one is that, clearly Docker was a big piece of the puzzle, both then and now. And Docker being written in Go was definitely influential. I actually insisted that we do it in Go because Brendan Burns, one of the other founders, the initial prototype for Kubernetes was written in Java. And I think one of the things that I looked at is, and then we also were influenced looking at Mesosphere, which was an older system that, some different, ideas being sort of used in Mesosphere for how you extend it and how you program it. But it's essentially a large C++ code base. And so I was looking at like, okay, do we want to do the C++ thing like Mesos? Do we want to do the Java thing with sort of the sort of, Apache sort of Hadoop type of thing that comes with Java? Or do we want to actually sort of go and look at the community and the quality of, the type of code that's being written and the interactivity of the community that we see happening with Docker? And I think that Go ended up being this really great mix of system level enough that it felt like you weren't sort of insulated from the things that you're running on, but still much more approachable, much more productive than something like C++. Because like finding new contributors, getting them productive in a large C++ code base is really hard. Now, that being said, I think that there are cases, and I think I've heard people criticize Kubernetes as being like Go written by Java developers. And I think there's definitely parts of the code base where you look at it and can definitely see that. But I do think that having Go as an approachable systems level language ended up being very much the right call for Kubernetes.
If you are interested in learning more about folks who have criticized Kubernetes for being an object-oriented like system written in Go, I gave a talk at FOSDEM last year called You Can't Have a Cluster Bleep Without a Cluster. And it talks about a lot of the anti-patterns in the Go programming language that I think came out of a more traditional object-oriented mindset. Not to pick on you and Brendan too much, Joe.
Yeah, well, a big part of it is that the community grew so fast and there were so many folks that came at the project without knowing Go beforehand. And so that both helped boost Go, but it also meant that they weren't necessarily, they were maybe experienced programmers, but not necessarily experienced in Go. And so I think that's kind of the result that you get. And I bet you there's a lot of code bases out there that look very similar based on the same sort of dynamics.
And I mean, it's a successful pattern, right? Like it's working for us. So I think it's interesting, again, going back to that lesson of evolution over time, how we got here and how we didn't necessarily wake up in the morning and sit down and say, we're going to go and build the system out this way. So really cool.
So one of the things that really sort of showed the value of Kubernetes to me was when, like in the beginning, there was always talk about, we're doing container orchestration, right? That sits on top of virtual machines, and Kubernetes sort of handles that for you. It gives you that abstraction, the pods and whatnot. So the level at which you could deal, the unit, right? You could deal with the sort of for deploying things. Basically, you didn't have to deal with the virtual machines and whatnot. So now that serverless, I'm doing air quotes, is a thing, right? We probably all know it's more of a marketing term than anything else, but still, the idea of supporting serverless on Kubernetes is a thing, right? So with the virtual kubelet project, that makes it possible. Along those lines, are you seeing Kubernetes as basically the platform that whatever the next deployment model is, right? We went from virtual machines, now it's more about containers, and then now we're doing the function as a service thing, and whatever the next thing happens to be, are you seeing Kubernetes as sort of the enabler, right? Whatever we come up with next, Kubernetes will be able to handle it through its extensibility.
I hope so. I think, I can't predict the future. I think the first thing to recognize is that like developers, engineers, we have this mindset of like, there's one true way to do things. And so we see these new technologies, they're shiny, everybody gets excited about it. But the reality, as you see this stuff play out over time, is that we only ever add stuff. We never remove stuff. I mean, just as an industry, right? It's like the mainframe business is actually a growth business for IBM. And so VMs aren't going to go away anytime soon. I think one of the things that we can do is that we can view this as a spectrum, and we can actually provide different gradations on, different stops on that spectrum such that folks can pick the right tool for the job as they're doing stuff. And I don't think even any application is necessarily a serverless app or a container app or a VM app. What you can say is like, hey, I'm going to do most of it using sort of a function as a service, sort of platformy, PaaS-y type of thing. And then like, I have this one thing I need to do that's like a machine learning model, and maybe I need to like evaluate that with containers. And then, I need to do something that's using some sort of big legacy monolith. And so, I'm going to be running that in, or, my big iron database, I'm going to be running that in a VM or on physical hardware or whatever, right? And that can all be one application using that sort of that set of technologies. And I think that's what we see as being more typical as you see these new technologies come forward, these new frameworks versus replacing the old thing. And hopefully Kubernetes is going to be flexible enough that it can actually be a good basis, a good starting point for, the next thing.
This episode is brought to you by DigitalOcean. DigitalOcean makes it super simple to launch a Kubernetes cluster in minutes. The DigitalOcean Kubernetes platform empowers developers to launch their containerized applications into a managed, production-ready cluster without having to maintain or configure the underlying infrastructure. They seamlessly integrate everything with the rest of the DigitalOcean stack, including load balancers, firewalls, object storage spaces, and block storage volumes. They even have built-in support for public and private image registries like Docker Hub and Quay.io. Developers can now run and scale container-based workloads with ease with the DigitalOcean platform. Learn more, get started for free with a $50 credit at do.co/changelog. Again, do.co/changelog.
Yeah, so John Calhoun was telling me that a lot of people look to the Kubernetes code base for kind of examples of patterns and things like this. You mentioned some of it being more sort of a different kind of mindset when it was written, but there are obviously going to be then good examples too, and they're the ones that are used according to John. So yeah, are there any specifics around how things are organized? One of the things that John mentioned was that it had to evolve so quickly. You sort of can't start with a good, clean design. And so you end up, everyone's is sort of going to naturally evolve anyway. So I think that in itself is quite a good lesson. But are there anything about code structure or anything about the project or other things for Go developers to take away from the Kubernetes code base?
So I think the Kubernetes codebase, in my mind, is probably the single best example of how to use Go interfaces. And especially when you're looking at more unconventional principles in Go, such as composition and embedding, I think we do a really good job with what we basically use object meta for, which is embedded in every Kubernetes object. That's a great example of how we're able to define generic bits and then share them across other objects that contain other specific bits to that object. So I think, again, this kind of alludes to like an OO style thought pattern, but I mean, these are first class features of Go, and I think Kubernetes does a really, really slick job at using these in clever ways.
I think, man, all I see are the warts, right? I mean, like, I think, Kubernetes has sort of lived through sort of having a mono repo, trying to split things out. It's kind of like half split out right now. I don't even want to describe sort of like, the current state of affairs in terms of trying to break the repo up. That's been a painful process to go through. So I think there might be some lessons to take away, the pros and cons of mono repos. I think the one thing we did get right, though, is, we wanted Kubernetes to be a well-structured, principled, distributed system. And so instead of creating a single binary out the gate, we actually took different capabilities and we broke that out into different binaries and had those things communicate to each other over essentially the same APIs that everybody else has access to. And so, I think structurally creating multiple binaries that can talk over the network and holding the line about sort of no private interfaces, I think, that's definitely a lesson to take away, maybe not for Go specifically, but for, as you start building distributed systems, sort of creating the right mechanisms to help, enforce a level of cleanliness of architecture, I think ended up being something that worked out well.
And I guess you're also dog fooding continuously as well.
Yeah, absolutely. I mean, we're totally dog fooding our own client. Like if you look at the actual official client Go for how folks would build a Go program to interface with Kubernetes, that's the exact same source code that we use internally in Kubernetes itself. So we're actually running the same code that we're prescribing folks to use to solve their own problems. So I think that's a really good pattern to take away here.
Yeah, I agree with that. And even just the fact it gets used a lot and you'll find any bugs. But there's actually a few other interesting side effects that we noticed as well at Machinebox, which is a similar kind of thing, where we use the SDK, we have a Go SDK for the Machinebox APIs, and we use that in our integration tests. So we kind of try and fold as much into the integration as we possibly can just to test as much at the same time. But yeah, it does provide that level of stability. And that's really interesting, yeah.
So John in the channel is asking if by Kubernetes being an open source project, has that sort of forced you down a particular path in terms of code structure and organization and how you package things up? Would you have done things differently if it was a sort of a private sort of a repository or private project?
I mean, from code structure, I don't know that we would have. I do think that there is there's a scale out of the community that, the code and the community co-evolve, which I think is an interesting thing in that as the project grew, we needed to have ways to actually govern who was in charge, who got to decide what features, how this stuff moved forward. And I think that this was, Kubernetes has been sort of what we call open governance now, where it's essentially an open set of folks that are actually deciding what the future of the project looks like. It's not controlled by any one company or anything like that. And I think there are places in sort of the code structure where we've actually seen that play out. I think the extensibility mechanisms are definitely amenable to sort of this open source sort of, let's let things go wide type of thing. So I think that, maybe we wouldn't have done this same level of investment in extensibility if we hadn't had the open source angle to it. I think, we've broken GitHub essentially. I mean, the size of the project and the workflows, there's essentially, this system called Prow that the Kubernetes community wrote that essentially is GitHub automation. And so essentially almost nobody has real admin privileges in the Kubernetes GitHub org. Instead, it's all, commands through like /test or /approve or /LGTM in the issues. And then it's the Prow robot that actually sort of does all the stuff there. So we can have a richer ownership model, a richer permissions model on top of that. That stuff's all written in Go also. But I think, that's not the code itself, but it is really sort of how the community, how the code processes work is definitely part of it.
There's something to be said about the speed at which we were iterating in Kubernetes. We've brought this up a few times now, which is, as an open source project, it moved very quickly. And I think we see that reflected in the Kubernetes K/K repository with the amount of binaries that we have in there and the amount of dependencies that we're vendoring. Not that I need to bring up Go vendoring on the Go time call. But yeah, I think that, it grew quickly. And I think because of that, we see the repository take a unique shape that we might not have seen otherwise.
So speaking of governance and sort of the influence of companies over a project, every time any popular open source project gets sort of at least the organization behind those projects gets acquired, or basically there's always a sort of this moment, this knee-jerk reaction moment where you're like, oh, there goes that project, right? Now you're going to start seeing things that are beneficial to one company and not to others. From an outsider's perspective, it appears as if Kubernetes hasn't suffered from anything like that with the acquisition of Heptio by VMware. But I'm curious to sort of at a glance, what would be, say, one or two of the most advantageous sort of benefits, right, since the acquisition that basically has benefited Kubernetes?
Well, I mean, so the first thing I'm going to say is that, Heptio, we contributed to Kubernetes. We weren't the largest contributor. I think, we probably punched above our weight based on the size of the company, but it's a pretty big pool that we were playing in. I think, one of the things that, my co-founder did while he was at Google was start the Cloud Native Computing Foundation and brought folks together. This is Craig McLuckie, the Heptio co-founder. And this ended up being sort of a vendor neutral place for, holding Kubernetes. And, there's pluses and minuses to the CNCF and the Linux Foundation. And there's, that's a whole nother conversation over drinks type of thing. But I think that, in general, having this not be owned by any single company has, I think, been one of the keys to success for the project and has actually let it sort of continue to thrive as we've seen sort of the ins and outs through sort of any sort of company, in the industry, whether that be Heptio or whomever. In terms of Heptio joining VMware, I think we were able to, activate a lot of folks inside of VMware, bring more people to the community, really start to fill in some gaps that we've seen through the eyes of our customers. And so, we definitely have a focus on making sure that we're putting more into the project than we're getting out of it.
So to kind of follow up on the government's commentary of earlier, I think Kubernetes was kind of the first of its kind and kind of set the pace and the tone and set the, for lack of a better term, reference architecture for a successful CNCF project. And if you look at tools like, Joe, you had mentioned Prow earlier, that's now an open source tool that you can vendor, and you see that being used throughout the CNCF ecosystem. And we're using it locally on our end for Falco, and I know a lot of other projects who are using it as well. And again, I think we just have Kubernetes to thank here for being the first one to kind of go through the CNCF graduation process and to kind of set the tone for a lot of the processes moving forward.
Very cool. As we wind down to the remaining few minutes here, I'm kind of interested in kind of knowing what the next big sort of steps or the next big features or improvements that you see in Kubernetes, or whether you think, you're kind of getting to the point where you're going to have more stable code base, just refining things, or do you see big pieces still remaining to sort of make the platform sort of complete, so to speak?
I mean, I've got an answer here, and obviously I'm a little bit biased, but if you look at the problems that we've solved as a community, we've already kind of addressed storage. We've iterated over storage a few times. We've done that with networking. We've done that with compute. We've even done that with how we define our applications and how we start to look at managing state over time. But if you look at the security space, there's not really a good story in place yet. And I think that's a bit of a final frontier for Kubernetes to figure out and solve. And there's a lot of known issues about running your applications in Kubernetes and keeping those applications secure, and even keeping your Kubernetes cluster secure. So in my mind, that's one of the big sort of like Joe said earlier, warts that I've noticed in the ecosystem.
I mean, just to be clear, it's possible to do. I think it's just not as easy or straightforward as turnkey as you need to. And I think there's more to be done there in terms of, I think from a security point of view, I think, Kubernetes in the fullness of time will become the high watermark in terms of, security best practices, because you end up with a heck of a lot more insight in terms of what programs are running, how they're running, who actually decided to run those things, who took what action, and you get all that data that you often don't get in sort of more traditional sort of DevOps types of situations. But I think we see the potential there. I don't think we fulfilled that potential yet. So I definitely agree with Kris on that. I think, one of the things we talk about a lot in Kubernetes in the core project is, making Kubernetes boring. Good infrastructure is boring, right? I think one of the, Brad Fitzpatrick, I think at one point talking about Go release said hey, there's nothing interesting in this Go release. And that's actually a good thing. Go has gotten more interesting since that time, I think. But, but there was a time where it's the thing was stabilizing and it got boring. And the release notes were we improved the garbage collector and things are faster, but from a user's point of view, nothing changed, right? And I think our goal is to get to that point where, the core of Kubernetes is super boring and all the interesting stuff is actually happening outside of that core. And I think we're continuing to sort of head down that road. And so I think that's a good place for us to be in, to actually have the excitement happening in the ecosystem, but not in the core.
I think it was the first time I heard somebody use the term boring to describe software. I think it was Rob Pike in one of his early talks when Go was first coming out.
Yes. Well, here's a quick question for you. If I write K8S, am I embarrassing myself? Is that hot or not? I don't know. Is that in still? Or?
Oh, that's in, yeah.
Oh, that's in.
So that is so just for those, it's how people write internationalization or localization is what is it?
I18N.
I18N, that type of thing. Where Andreessen Horowitz, right? I16Z, right? All right, it's that same type of thing where it's between the K and the S, there's 8 letters, right? So, but then we also have the advantage that you can call it Kates. And so a lot of times when people are reading it, instead of calling it Cube or Kubernetes, they'll actually call it Kates. I don't know who started that. It's both cool because it's like a shorthand, but it also, I think, is one of those things that creates a little bit of a barrier for new folks to the Kubernetes world because it's yet another sort of piece of jargon to learn. It's okay, Kubernetes, but then I see Kates. What the hell's going on with that?
Yeah.
Oh, I was going to say, I just really like it because it minimalizes the amount of characters I need to talk about Kubernetes on Twitter.
That is useful, yes. So speaking of more sort of jargon, is it kube cuddle? Is it kube control? Is it
Kubectal? Well, I mean, so is it IO control? Is it ioctal, right? I mean, like, we argue about this stuff all the time, right? We had one employee, Heptio, now at VMware. She insists on mispronouncing Kubernetes as Copernicus. So it's kind of a game we play about sort of finding the worst pronunciations for anything that we talk about.
Awesome.
And the last question for you, Nova. There's 85,000 commits in the KK repo. Which one's your favorite? And I will accept the short hash.
Which commit is my favorite? Let's call it Joe's commit. Joe holds the official title of the very first commit to the open source repository. And if it wasn't for that, then I don't think any of us would be here right now.
Oh, that's a great answer.
There you have it.
Well, okay, I just want to argue against that. What happened is we had a repo before we actually sort of moved it to GitHub and started I was just doing janitorial work of actually sort of saying, okay, let's get this thing ready for release. And so it's I can't claim that I wrote all that code. I just was the one who checked in the first code as we were sort of cleaning stuff up to do the initial release.
I think the GitHub history doesn't lie, and it is admissible in court.
You can revise that history, right? Just saying.
Can you?
All right. Well, I think this has been really one of the funnest shows I've been on because I have a penchant for infrastructure and whatnot. And it makes me happy as an SRE. It makes me happy to know that boring technology is what we want because I don't want exciting when I'm on call. So, yeah, it's great to know where the project is headed. And it's been awesome having the two of you on the show. And I know, Joe, you do have on a regular basis TGI Kubernetes that you host live where we watch you sometimes stumble on things. But most of the time you get through it with the assistance for everybody else.
Well, yeah, and I think we're on show 90 something there, so we do this every Friday, and Nova also hosted a large number of those too when she was working at Heptio, and so and I know that she's looking to start doing some of her own streaming on Twitch too.
Ooh, nice. We're looking forward to that, Nova.
Yeah, we did our first one and we're working on kind of building it out. I think we're going to focus more on Kubernetes and other container orchestration, so broadening the scope a little bit. And of course, we're a security company, so I'm sure we'll see a lot of security talks.
Great. We look forward to watching, I suppose.
Yeah, I think that's the correct word to use there.
Yes, thank you. I was just checking.
Cool. Waiting for the confirm.
It's weird that, sort of the streaming sort of YouTube, Twitch stuff has sort of a different feel to it than podcasting, right? And I think it's consumed in a different way. And so I think it's interesting sort of seeing the different mediums sort of find their own way of working. Yeah,
when you first start streaming, there's this moment when you're halfway through and you realize you've just been in a tiny room talking to no one for 30 minutes. And it's really easy to kind of go off the deep end a little bit there.
Awesome. Well, thank you very much for coming on the show. And for those of you listening live, we appreciate your being on the channel and asking questions. And for those of you who will be listening to the show later on, we hope that you enjoyed it. And please reach out to us on Twitter, GoTimeFM. Let us know who you'd like to have as guests. We can always reach out to these exciting folks and come talk about the stuff you know and love and go. So thank you very much. And this is it for us.
Thanks so much for having us on.
Yep, thanks.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us in Gopher Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.